Welcome, my dear learners, for this course on operations research. In this module 3, we were discussing on transportation problems. So far, we have solved problems on northwest corner rule, least cost entry method or matrix method, Vogel's approximation, and also we have learned how to obtain the optimal solution by using stepping stone method. Moving ahead in today's lecture, let us solve a problem on transportation problem and learn how to obtain the optimum solution by using modified distribution method or MODI method. The problem number 3 of our discussion on transportation problem states that a company has 3 production facilities S1, S2, S3 with production capacity of 7, 9 and 18 units per week of a product respectively. These units to be shipped to 4 warehouses D1, D2, D3, D4 with requirements of 5, 8, 7 and 14 units per week respectively. The transportation costs in rupees per unit between factories to warehouses are given in the table 2. Determine the optimum allocation in order to minimize the total transportation cost using Vogel's approximation method and modified distribution method. So this is the cost matrix given for transportation from factories to warehouses, and he has specified the supply, that is production capacity, and also he has specified the demand, that is requirement. Now using Vogel's approximation method we should find the basic feasible solution, then by using modified distribution method we should find the optimum solution. Come, let us solve this problem number 3, make it as table 3. Since we are solving problem number 3, make it as table number 3. That sounds good. Next, moving for the solution, since we are solving for basic feasible solution using Vogel's approximation method, let me solve for Vogel's approximation method, that is Vogel's approximation, Vogel's approximation method, which is also called as penalty method. According to penalty method, we have the cost matrix as S1, S2, S3, right, and we have demands as D1, D2, D3, D4. Now let me write the matrix. We have the cost as 19, 30, 50 and 10. Here we have 70, 30, 40 and 60, and finally we have 40, 8, 70 and 20. So this is what we have. Now as usual I should write down the supply, that is requirement, and demand. I should formulate the supply and demand. So supply units are 7, 9 and 18. Coming for demands or requirements, it is 5, 8, 7 and 14. Check whether it is a balanced assignment problem or not, for which supply is equal to demand, that is 7 plus 9 plus 18, which is 34, should be equal to the demand of 5 plus 8 plus 7 plus 14, which is also 34. So it is a balanced assignment problem. We have supply is equal to demand. Since Vogel's approximation method is an penalty method, so we want to calculate row penalties. Row penalties we should calculate, and also we should calculate column penalties. Right. Now we will calculate the row penalty as well as the column penalty. First, for first iteration, the row penalty is calculated as minimum of the difference between the second minimum and first minimum cost. The first minimum cost is 10, second minimum cost is 19. So 19 minus 10 is 9. Next, coming for the second row, the least cost is 30, second least cost is 40, 40 minus 30 is 10. Next we have the least cost as 8 and second least cost is 20, 20 minus 8 is 12. Next, coming for column, we have the least cost as 19, second least cost as 40, so therefore 40 minus 19 is 21. Next, here we have least cost as 8, second least cost as 30, so 30 minus 8 is 22. Next, we have least cost as 40, second least cost as 50, difference is 10. Next, we have 10 and 20, difference will be 10. Right. So among the penalties, the highest penalty is 22. So therefore, first allocation should go here. So here we have demand as 8 and we have supply as 12. So this will become the key cell because we have the least cost as 8. So this has become the key cell. So here we have the demand as 8 and supply as 18. Supply is 18, demand is 8. So minimum of 8 and 18 is 8. So this is not available for further allocation. So since I have allocated 8, so this is reduced to 10. So this completes the first step. I calculated the penalties. Among the penalties calculated, I found out the highest penalty. In that cost matrix, cost column, I have identified the least cost. Least cost is 8. So therefore this will become the key cell. Now compare demand and supply. So demand is minimum, so therefore allocate the demand. So subtract the demand allocated from the supply and make a note of it. Since it is completed, this is not available for further allocation. Right. So next, similarly we calculate the penalty again for second trial. So now the penalty remains same. It is 19 and 10 we have, hence the penalty is 9. Here we have least as 40. Now second least has become 60. So therefore penalty is 20. Next, coming over here, the least is 20, second least is 40, hence the penalty is 20. Next, coming over column for second penalty calculation, here we have 19 and 40, so therefore this remains same, 21, this is ruled out. Next we have 40 and 50, that is 10, this remains same. Here we have 10 and 20, hence the penalty is 10. So I calculated for second iteration. So row penalty and column penalty. Among the calculation, I found that 21 is the highest penalty. So in this column of cost matrix, the least cost is 19. Hence this is the key cell. Now the demand is 5, supply is 7, minimum of 5 and 7 is 5. Hence I should subtract 5, this will become 2. And this is not available for further allocation. Now move for step 3. Now if I calculate the penalties, it is 10 and 50 is penalty is 40. Here we have 40 and 60, penalty will be 20. Here we have 20 and 70, penalty will be 50. Next, coming over here, these two are ruled out. Here we have the penalty as 10 and here also we have penalty as 10. In step 3, if you observe, the highest penalty is 50. So this is the highest penalty. So in this row, if I compare, I have the least cost of 20. So therefore 70 and 20, least is 20. Therefore this is the key cell for me. So I should go for allocation. For allocation I have supply of 10 and demand as 14. Least among these two is 10. So therefore this will become 4. So now this is not allowed for further allocation. Right. So this row is not allowed for further allocation. Done. Now we have remained with these 4 cells. Now moving for trial number 4, the difference will be 40. Here the difference will be 20. Now coming over to column, here the difference will be 10 and here the difference will be 50, right? 60 and 10 is the remaining, so difference will be 50. So therefore I should go for this one. If I go for this one, minimum is 10, so here we have supply as 2 and demand as 4, so I left out with 2. Supply is 2, therefore I allocated 2, so 2 will get cancelled, this 4 will changes to 2 now, this 4 will changes to 2, so hence here nothing is left out, so therefore we have done with this row, correct? Here nothing is left out, so therefore this row is done. Now we are left out with only 2 positions. We have left out with allocations of 2 and 7. So this 10 I allocated here, this is cancelled, sorry. Now I left out with only 2 and 7, so therefore I should put 2 here and 7 here. So this completes the allocation. First I calculate the penalty as 9, 10, 12, 21, 22, 20, 10, 10. Highest among the penalty is 22. So therefore least cost in this column is 8. So we have demand as 8 and supply as 18. Least is 8. So therefore I allocated 8 and this is eliminated. So remaining is 10. Next in the second trial I calculated the penalties. Highest penalty is 21. In this column the least cost is 19. So therefore this will be the key cell. For this key cell demand is 5, supply is 7, least is 5, therefore I allocated 5, remaining is 2, so this is eliminated. Next in the trial 3 I calculated the penalty. I found the penalty as highest for 50. So therefore in this row we have left out with only these 2 cells. Among these 2 the least is 20. So therefore this is the key cell. For the key cell we have the allocation as 14 and 10. So 10 is minimum, I allocated 10, remaining is 4. Next I calculated the penalty and I found that the highest penalty is found to be 50. Correct? The highest penalty is found to be 50. The highest penalty is found to be 50. So these 2 positions are left out. The least is this one, therefore this is the key cell for which the allocations are supply is 2, demand is 4, so hence I allocated 2, so this will be ruled out and this will become 2. Now I left out with only these 2 cells and I have only 2 allocations as 2 and 7, so therefore these 2 have been allocated. So that completes the initial basic feasible allocation and cost. So therefore initial basic feasible solution from Vogel's approximation method is, so in step 1 from VAM, initial basic feasible solution, basic feasible solution is, so we have supplies as S1, S2, S3 and we have the demands as D1, D2, D3 and D4. $19, $30, $50 and 10. Here we have 70, 30, 40 and 60. Next we have 40, 8, 70 and 20 as the cost. Coming for allocations, we have 5 here. Next here we have 2. Next for 40 we have 7. For 60 we have 2. And for 8 we have 8. And for 20 we have 10. Now if I add to cross verify, it should turn out to be 34. 5 plus 2 plus 7 plus 2 plus 8 plus 10, which is 34. So number of allocations are 1, 2, 3, 4, 5 and 6. We have totally 6 allocations and we have 3 rows and 4 columns. So the number of allocations is equal to the number of allocations is equal to 6, which is equal to m plus n minus 1. That is 3 plus 4 is 7 minus 1 is 6. So since allocations is equal to m plus n minus 1, we have got non-degenerate basic feasible solution. This is an initial non-degenerate basic feasible solution. Let me calculate the total cost. So total cost is how much? Rupees 19 into 5 plus 10 into 2 plus 40 into 7 plus 60 into 2 plus 8 into 8 plus 20 into 10, which is turning out to be 779. Let me calculate once again. 19 into 5 plus 10 into 2 plus 40 into 7 plus 60 into 2 plus 8 into 8 plus 20 into 10, which is turning out to be rupees 779. So from the Vogel's approximation method, we have found out the initial basic allocation as well as the initial cost, total cost, which is found to be 779 rupees. Now using modified distribution method, I should find the optimum solution for this problem, for this allocation. Let us do that. Now moving ahead for optimality test, that is in step 2, that is in optimality test, we will be using modified distribution method. Now in modified distribution method, which is also called as UV method, let me explain UV method. First let us write down the cost matrix and with allocations. We have in trial 1, so write down only the cost matrix with allocations. 15, allocation is 5. Next we have 30. Next we have 50, and then we have 10. Here we have 70, cost is 30, then we have 40 and 60. Next we have 40, 8, 70 and 20. Coming for allocations, we have 5, 2, 7, 2, 8 and 10. Now we will calculate the values of u's and v's. So these are called as ui's, that is u1, u2, u3. Here we call it as v1, v2, v3, v4, such that ui plus vj is equal to cij, that is the cost. Always we start by allocating u1 as 0 and we calculate v by using the allocated cell. So among these, the allocated cell is this one, right? So since u is 0, cost is 19, so therefore v1 should be 19. v1 should be 19. Since v1 is 19, we don't have any allocated cell, leave. Since u1 is 0, v4 should be how much? 10. Cost is 10, right? ui plus vj is cj, cost is 19, u is 0, so therefore v should be 19. Cost is 10, u is 0, therefore v should be 10. Since I know v, I can calculate u2, right? v4 is 10, so next allocation is here, cost is 60, so 60 minus 10 is 50, so 50 plus 10 is 60, right? Since u2 is known, I can find v3, so cost is 40, u2 is 50, so therefore v3 should be minus 10. V3 should be minus 10. 50 minus 10 is 40. 50 plus 10 is 60. Correct? Next, I know the value of V3. Now I can find what is the value of U3. So it is not possible. From this it is possible because there is no allocation here. So therefore using V3 I cannot find U3, but using V4 I can find U3 because we have allocation here. Cost is 20, V4 is 10, therefore U3 should also be 10. 10 plus 10 is 20. Next you have to find V2. I will make use of U3. U3 is 10, cost is 8, so therefore V2 is minus 2. So 10 minus 2 is 8. Hope you followed. Always write U's for rows and V's for columns. Start by giving U1 as 0. Using the allocated cell cost, using the formula Ui plus Vj is equal to Cij, find out V's and U's. First U1 is 0. Next I found here the allocation is 5, therefore 19 I can use. So U plus V is 19, U is 0, therefore V should be 19. Next my inspected I found here, since U is 0, V should be 10. Next using V4, we have allocation here, I found out U2. That is 50 plus 10 is 60. Next using U2, I found out V3 because 50 minus 10 is 40. Next using V3, I could not find anything, but using V4, I could found U3, right? Because we have allocation here, V4 is 10, therefore U3 should be 10. 10 plus 10 is 20. Next using U3, I found out V2 because we have allocation here, U3 is 10, so therefore V2 should be minus 2. 10 minus 2 is plus 8. So thereby I found out the values of U's and V's. So this is the first step. Next, using the same logic, find out how much is the difference here. Now we have unallocated cells. Use the formula for unallocated cells. For unallocated cells, find cost minus Ui plus Vg. Cost minus Ui plus Vg. Using this formula we have found out U's and V's. Now using this formula you find out fill the unallocated cells. So now cost is 30. 30 minus sum of these two. So cost is 30. 30 minus 0 minus 2, which is 32. Next here cost is 50. 50 minus U is 0, V is minus 10, which is 60. Next coming over here, cost is 70 minus sum is 50 and 19, that is 50 plus 19, which is plus 1. Next coming over here, cost is 30 minus U2 is 50 and V2 is minus 2. 50 minus 2, which is turning out to be minus 18. Next we have unallocated cell here, Cj is 40, Cij is 40 minus of U3 is 10 plus V1 is 19, which is equal to plus 11. Next we have one more unallocated cell here, cost is 70 minus U3 is 10 and V3 is minus 10, so it remains as 70. So out of the unallocated cells we have 32, 60, 1, minus 18, 11 and 70. The least is minus 18. So therefore this is beneficial for us. So now for this we should find out the allocation. So since this is beneficial, I will rewrite this once again. So that will gives us the allocation as optimum allocation as 30, 50, 10. Here we have 70, 30, 40 and 60, right? So finally we have 40, 8, 70, 20. Clear? And the allocations are 5, 2, 7, 2, 8 and 10. Whatever we are computed in the brackets is nothing but the values which is obtained by Cij minus Ui plus Vj, among which find out the least value, that is the most negative value. Only negatives I should consider. So minus 18 is decreasing the total minimum cost of transportation. So therefore, if I allocate here, it will further reduce the transportation cost. So since we have penalty as minus 18, that is 30 minus 50 minus 2, so 30 minus 48 is minus 18, correct? Now allocate here as theta, so allocate here as theta and form the loop. So if I form the loop will be like this, correct? If I form the loop will be, I should get the loop. So if I go here, I cannot come here because loop is formed with the allocated cells. So therefore the loop will be like this. Go here and I will come here, come back here, and then I will come here. Because in the stepping stone method, I explained how to form a loop. Loop is formed by using only horizontal and vertical lines, such a way that you should move from an unallocated cell to all located cells and come back and form a loop. So from here, if I go here, I cannot come down. I cannot move up also because there is no allocation. So therefore I should jump and move here. So then I can come down, come here and come here because we have the allocations. So since we have plus theta here you give minus theta, here you give plus theta, here you give minus theta. So this key cell is identified by using this technique, U's and V's technique. So using U and V, identify the key cell for optimization. So then using that cell, form the loop, like how we are forming in the stepping stone method. So once you form the loop, now allocate alternative plus and minus thetas. Now find out what is the maximum value of theta that can be allocated such a way that the allocations will not become negative. Now if I give theta as 8, this will become 0, but here it will become minus 6. So allocation will become negative, which is not possible. So therefore the maximum value of theta that I can give is 2, because 2 minus 2 is 0. Here I have 8 minus 2 as 6, so it is possible for us. So therefore the theta I can give as 2, hence the allocation in trial 1 and the cost is found to be 19, 30, 50 and then we have 10. Here allocation is 5, here allocation is 2. Next we have 70, 30, 40 and 60 and then we have 40, 8, 70 and 20. So from the inspection it is found that theta can take only the value as 2. So instead 2 minus 2 will become 0. Here I will get 2. 8 minus 2 is 6. Here I will get 7 as it is. Here I have 10 plus 2 is 12. Now check the total cost. Check the total cost. We have 19 into 5 plus 10 into 2 plus 30 into 2 plus 40 into 7 plus 8 into 6 plus 20 into 12. So the cost will be 19 into 5 plus 10 into 2 plus 30 into 2 plus 40 into 7 plus 8 into 6 plus 20 into 12, which is found to be 743 rupees. 743 rupees. Now for this allocation, again I should find U's and V's and also calculate the penalties by using the formula Cij minus Ui plus Vj. And if I get all the entries in the unallocated cells as positive value, then the problem terminates, and that is the optimum allocation and that is the optimum. total cost. So now I want to investigate this, whether I'll get any negative values like what I got minus 18. That if I get any negative, then again the optimum allocation will be revised and the optimum cost will also be revised. Now let us check this one in trial 2, that is, now moving for trial 2. So allocation what we obtained in trial 1 is, let me rewrite that one to calculate. We have the cost as 19, 30, 50 and 10, and here we have cost as 70, 30, 40 and 60, and then we have the costs as 40, 8, 70 and 20. In step 1 we got the optimum value as rupees 743 and also the allocations as 5 and 2. This 2 has become 0 and here we gave 2, so minus, here it will become plus, so 10 plus 2 is 12 and 8 minus 2 is 6. So this is what we had, the allocation, and the value we have 7 here, right? So this is the allocation what we had, 6 allocations, and the optimum rupees is found to be 743 rupees. Now I should inspect this whether I'll get all the values in the unfilled positions as positive or not by using U's and V's. First let us calculate U and V, V1, V2, V3, V4. Give U1 as 0 using Ui plus Cj is equal to Cij only for allocated cells, correct? Only for allocated cells we should use. So we have allocation here, so therefore Cj cost is 19, so V1 should be 19, 19 plus 0 is 19. So since U1 is 0, we have allocation here, so V4 should be 10, 0 plus 10 is 10, cost is 10. Next V4 is 10, we have allocation here as 20, so therefore U3 should be 10, 10 plus 10 is 20. Next you have U3, so therefore here I have cost as 8, so therefore V2 should be minus 2, 10 minus 2 is 8. Since V2 is minus 2, here we have allocation, so therefore U2 should be 32, right? 32 minus 2 is 30, 10 minus 2 is 8, correct? So since U2 is 32, here we have allocation as 40, so 40 remaining is 8, 32 plus 8 is 40. Now I got U's and V's. Now calculate for unallocated cells. For unallocated cells, find Cij minus Ui plus Vj. So your cost is 30, 30 minus 0 minus 2, which will become plus 32, which is positive. It is undesirable for us. Here we have 50, 50 minus 8 is 42, which is also not desirable for us. Next here we have 70, 70 minus 32 plus 19, which is plus 19, which is also undesirable for us, positive value. Next here if I calculate 60 is the cost minus U2 plus V4, that is 32 plus 10 is plus 18. Next here 40 minus 29, which is plus 11, which is not desirable. Here also we have 70 minus 18, which is 52, which is not desirable. So all the values which has been calculated in the unallocated cells are positive, hence the problem terminates. So therefore the allocation what is present itself is the optimum allocation, hence the optimum allocation Hence the optimum allocation for this problem is, we have 19, 30, 50 and 10. Here we have 70, 30, 40 and 60, and finally we have 40, 8, 70 and 20. Coming for allocations, it is 5 units, 2 units, 2 units, 7 units, 6 units and 12 units. So if you count, it should be 34. 5 plus 2 plus 2 plus 7 plus 6 plus 12 is 34, correct? And the minimum transportation cost is minimum transportation cost equals rupees 743, right? That is 19 into 5, 19 into 5 plus 10 into 2 plus 30 into 2 plus 40 into 7 plus 8 into 6 plus 20 into 12, which is 743. So we found out the optimum allocation and minimum transportation cost by using modified distribution method. So modified distribution method is also called as UV method. So this is how we will solve for optimality using modified distribution technique. The same problem is solved in the previous lecture by using northwest corner rule and stepping stone method. Now we have solved using Vogel's approximation and modified distribution method. If you observe, Vogel's approximation and modified distribution method are considerably faster when compared to stepping stone method. Modified distribution method is fast, and compared to northwest corner rule, Vogel's approximation method is fast. Hence, unless otherwise specified, always use Vogel's approximation method to find the initial basic feasible solution and modified distribution method to find the optimum solution for the transportation problem. So this is how we will use modified distribution technique to find the optimum solution for a given problem. So this is the solution for problem number 3. That's all from this lecture. Thank you all.